Hello everyone, I am Anil Kumar, a final year graduate student at India-based Neutrino Observatory INO. I am going to present this poster on validating the Earth core using atmospheric neutrinos with ICAL at INO. ICAL detector at INO can distinguish neutrinos and antineutrinos separately in the multi-GeV range of energy with a muon energy resolution of about 10% and an excellent angular resolution of less than 1 degree. In this work, we consider simple 3-layered structure of Earth which has core, mantle and crust, and based on that we consider few profiles, for example core, mantle, crust profile, and a 2-layered profile of mantle and crust which does not have core, and similarly some other profiles like core and mantle and uniform density. When a neutrino passes through Earth, it feels the presence of matter because of the interaction with the electrons present inside the Earth. Because of this interaction, there are two types of resonances occurring. One is the MSW resonance, which occur when neutrino passes through mantle. Another is the oscillation length resonance or parametric resonance, which occur when neutrino passes through core. In this probability oscillograms, we show survival probability of muon neutrino for two cases. On the left we show prime profile, on the right we show mantle crust profile which does not have core. And we show this oscillogram as a function of energy and direction of neutrinos. So here we see this dark blue diagonal band which represent oscillation valley, and there are some patches which represent matter effect. So this big patch represent MSW resonance, and these smaller patches at lower energy and higher baseline, they represent parametric resonance. In the right plot we see that if the core is not there, this MSW resonance it get disturbed, but it is still there, and if you look at the parametric resonance, then we observe that it is totally gone. So now to look at this effect at the detector level, we generate events at the ICAL using neutrino flux at INO site with nuanced neutrino event generator, and we use the migration matrices obtained from Geant4 simulations and apply those detector properties on our events. So after generating the reconstructed muon events, we observe that about 331 mu minus and 146 mu plus events will be observed for core passing neutrinos and antineutrinos respectively. So in the bottom panel we show that two plots where we show the distribution of these core passing events. We see that although these muons, they are aligned with the neutrino direction, but they show some smearing also, but it is good that most of the directional information is retained by the reconstructed muons. So next we calculate delta chi square by considering prime profile in Monte Carlo data and various profiles in theory. So for example, this blue row we see that the mantle crust profile which does not have core, this profile can be ruled out with respect to the prime profile with a delta chi square of 7.45 for the case of normal ordering, and if we consider the inverted ordering, then this result drops to 4.83, and in both of these results we have considered the charge identification capability of the ICALs. If CID capability is not there, then these results will drop further. So in summary, we can say that using 10-year data at ICAL, we will be able to validate the presence of Earth's core with a delta chi square of 7.45 for normal ordering and 4.83 for inverted ordering, and in this result the charge identification capability of ICAL will be playing a very crucial role. Thank you.